Hello and welcome back to our YouTube channel, Kotlin by JetBrains. And today we are back with the new series of webinars. If you are subscribed to our channel, you will probably see the announcements right away. But if you are not subscribed yet, you probably should hit that subscribe button and set the reminders for the new upcoming webinars that we have just announced. So on my screen, you can actually see the dark squares. Those are the webinars that are basically announced for this series. We have AWS SDK for Kotlin today, and we have some more exciting and interesting webinars coming uh, throughout the next month. So hit those buttons to set the reminders, and don't forget about the event, right? So, and with that, I would like to bring in Ian, who will be the presenter today. Hello, Ian.
Hi, Anton.
How are you doing today? It must be very early morning for you, right?
It's 9 o'clock in the morning, so it's not too early. It's
Okay, it's
start of a
light.
start of a beautiful
I,
day here.
I can see there is a window on the side, and it's light there because it's
It's that's
currently
because
very
it's snowing outside actually, so it's very bright right now.
right. It's very dark here on my side, so it's already quite an evening here. So,
Yeah,
Ian, you are the developer on the new SDK for Kotlin, right?
well, I'm one of them certainly. Yeah, I'm part of a team of developers working on the Kotlin SDK. I've been part of the team for about a year, but the work has been going on a little bit longer than that.
Nice, nice. How long have you been working? How long have you been part of the team, actually?
I've been part of the team for just about a year. I started in March of last year, so it's been almost a full year, and we've come a long way since then.
Nice, nice. So last year at AWS reInvent, you announced the new SDK, AWS SDK for Kotlin, and this is what we are going to look at today. And I hope there is a nice showcase that you have prepared for us, right?
Yeah, that's the plan. And we're going to go through a couple of links and helpful documentation, and then most of this demo is going to be live code. So hopefully you and everyone else out there will be patient with me if I make a mistake or two while we're coding this up.
Yeah, people. Our attendees love live coding. I think, and well, I'm excited too. So let's start. I think let's not wait for the exciting live coding session.
All right. Well, first off, I'm going to start us with a couple of links where people can get information about what we're going to be talking about today. The first thing to show is kind of the link to the SDK itself. The page that this links to talks about what the AWS SDK is, kind of how it works a little bit. Right now, the AWS SDK for Kotlin supports two platforms. It supports vanilla JVM and Android JVM. And it's the connection between your client side code and the AWS services like S3, EC2, Lambda, so on and so forth. One thing to note about this SDK is that it's in what we call developer preview, which you can think of kind of like beta. We're still developing it actively, we're still adding features to it, and right now we don't recommend you rely on it for your production workloads. But that being said, we are very interested in getting feedback from the community about what we're doing right, what kinds of features they want to see, so that we can fill those into our roadmap and get it ready for a full general availability release. Switching back to the IDE, another thing that I wanted to show you was our GitHub repo. So all of the development that we do for the SDK happens in a public GitHub repository. You can go to this GitHub repo yourself, see what we're working on, see what we're committing, get more information about how to get started with the SDK, even contribute pull requests or issues if you'd like to. Um, since all this happens in our public GitHub repo, it should be easy to find. And then the last thing I'll point you to before we get started with the actual interesting stuff is our developer guide. This developer guide is really the the place to get started if you're brand new to the SDK and you want to understand how to get it configured, how to get it set up, maybe how to even get an AWS account set up if you don't already have one of those. This developer guide goes through that in a bit of detail. So recommend checking that out, especially if you're new to AWS. With that being said, let's hop back over to the IDE and let's get started with some real coding. The first thing to show is how to actually begin using the AWS SDK from your Kotlin project. And to do that, we're going to open up build.gradle.kts. Here's just the shell of a Kotlin project that doesn't have any dependencies configured yet. And what we're going to do is add a dependency on the AWS SDK. So, invitation aws.sdk.kotlin. Um, each of the services in AWS are pulled in separately as separate clients or separate dependencies. So in this case, if I wanted to use DynamoDB, for example, I would pull in just the DynamoDB dependency. If I wanted to pull in more dependencies, maybe a different AWS service, I could pull those in alongside of this. But what this does is it allows us to keep deployment sizes small so that we're not deploying a bunch of clients to your jar, to your class path that you don't actually need. And then after we make changes to this Gradle configuration, we'll need to refresh our Gradle config in the IDE so that it picks up all of these packages that we've just pulled in. All right, once that's done, we're all configured, we're all set up to begin using the SDK. Now let's actually write some code. And we're going to write a basic hello world example here, making a call to an AWS service. So the first thing to do here is to create a main method um, and then instantiate one of our clients. And the client I'm going to instantiate is a DynamoDB client. And we're going to go through each of the things that I'm writing here in more depth in future sections. So I'm going to put a bunch of stuff out here on the screen and then explain it later. But for right now, know that we're just creating a client. We're going to call an operation. We're going to call it the list tables operation, which is going to list all the tables that DynamoDB has in our account. And then with that response, we're going to say that we found these tables. We're going to iterate over each table, and we're going to print out the name of the table. I did everything right. If I pulled in all my dependencies properly, then when I run this, we should see, yes, the calls that I expected. So the tables that it found in our account are a table called hello and a table called world. And this was my trivial hello world demo for making an AWS account or an AWS SDK call. All right, but there's a lot of stuff here on this page, a lot of stuff that we'll have to go into a little bit more detail of to describe how it works. And the first thing is, what are we doing with creating this client? How does creating a client work to talk to AWS? So there's a couple of different ways to instantiate AWS clients. The first is kind of the one that I just showed on that last demo, which is create a client by calling from environment. And what this does is it inspects the environment that the program is running in to try to pull all the configuration that it needs. AWS clients actually need quite a bit of configuration behind the scenes. They need to know what region you're connecting to AWS from. We have regions in the US and Europe and Asia, all over the place. And the region that you call from makes a difference based on your latency, based on what data is stored in that region. But that can be detected from the environment that you're running in. Similarly, there's configuration for how to get credentials to call into AWS. All calls to AWS are authenticated using account credentials, and it can detect what credentials to use from your environment if that's set up in a profile file or with some environment variables. There's a whole bunch of other things that can be auto-detected here, and in a lot of cases, especially if you're running your code from EC2 or from Lambda, then simply calling from environment will get you the fully configured client quickly and easily. That being said, there may be situations where you need to detect most things, but override something. That situation, you can again instantiate an S3 client or whatever client you need to use this from environment construct, but then override what configuration you need in this Lambda block that gets passed to the client instantiator. So here we could say something like, don't auto detect the region, instead use this US East 1 region that I know about. Or don't automatically pick which profile or which credentials to use. Instead, pick credentials out explicitly from my profile file that I have set up on my computer. This will save it from going through looking for environment variables, looking for other places where credentials might be. It's a way of specifying your client with more precision. And then the last mechanism for creating a client involves not trying to detect anything whatsoever. Uh, that in that situation, we can create an S3 client. We can not call from environment and simply pass in everything that we want to directly to the client in this Lambda block. Here would be where we could set even more advanced parameters like overriding the HTTP engine that's used under the hood for the client. By default, we use our own homemade HTTP engine, but maybe there's a reason why you would want to use the Ktor engine that we provide instead. If you're already using Ktor, for example, in your project, it might be useful to pull in the Ktor engine. So let's see an example of how that would work in this client configuration. To do that, we would need to add an extra dependency in our Gradle file for the Ktor engine that's been created for us. So the SDK ships with a package called HTTP Client Engine Ktor. Um, if we pull this in, and if we refresh our Gradle configuration, then we'll be able to hop back over to our client configuration and override the HTTP engine with the Ktor variant. Again, this is a bit of an advanced configuration option. You may want to do this if you're already using Ktor in your project, but there's no reason why you can't simply use the default engine with your project. All right, but these are kind of three different ways of constructing, in this case, an S3 client, but these options apply to any service client that you can use from AWS with more or less specificity on what you want. All right, with that, let's jump a little bit more into making calls with the AWS SDK. So there's a couple of different options for how you make requests with the SDK. In this case, I'm going to start us off with an S3 client. We're just going to use that basic from environment constructor because we're okay with detecting everything. Now, the first way that you can make requests is by creating explicit request objects. So we can say we want to create a request object for listing objects from an S3 bucket. Then we can pass in the parameters that we want to this request inside this Lambda block. For instance, whenever you list objects from S3, you need to pass it a bucket that you're going to list the objects from. It won't list objects from every bucket. So we'll say, I want to list objects from this particular bucket. And then from there, we'll call S3. We'll say list objects v2, and we'll pass in that request. Now, just calling this list operation will actually make a call to AWS and return a response. But unless we save the response into a variable or do something with it, then we'll kind of lose the results of that request. So let's save the response, and then let's print out all the objects that we found. So in this example, we're creating an explicit request. We're calling list objects v2. We're going to print out all the objects that we find. Let's see what happens. Hmm. Oh, it doesn't like that I named all these clients the same thing on the previous example. We'll close that and try this again. And the joys of live coding. Okay, so it made our call to S3. We found a hierarchy of objects in our bucket, various GIFs of things, and this is what we kind of expected to see with our request. Next up is a different syntax for making the exact same request, but in a way that may be perhaps a little bit more streamlined. So rather than creating an explicit request like we did up here, we can pass parameters to the operation directly using the same Lambda syntax. So we can say response2 equals S3 list objects, and then pass in the same parameters as we did to our explicit request to the operation itself. From there, we can the same things that we found before. In this case, we need to print what we found in response to. But this should have the exact same effect as we did previously. So maybe it's not super interesting. Maybe we should actually pass another parameter here. Um, Say, let's limit the objects that we scan to those that start with a particular prefix. And then run this. So here we found a second set of objects. This is from our second request. Again, it's limited to just the objects that start with the prefix that we specified. But it's otherwise very similar to the first request we made. We just no longer have an explicit request object. Um, I personally prefer this syntax. I think that it shortens programs and makes them a little bit easier to read in a lot of situations, but there may be cases where an explicit object helps make your program more clear, more the intent more obvious. So you've got the flexibility to do it either way that you prefer. The last thing to kind of show here is what happens when we have a streaming operation and how we handle those responses. So for these first two demos that I showed, the responses were not streaming. They're available all at once to the caller, and we're able to save them into a response object and do what we want with them. But there are some operations that don't return just a solid response. They return a streaming response. And in those cases, we need to handle the result a little bit differently. So I'm going to create another object here. This is going to be a get object request. What we're going to do here is actually retrieve one of the objects out of our bucket, one of these files that's stored in S3. So we're going to specify the bucket that we need, specify the exact key of the object. I've forgotten already what the keys of my objects were, so I'm just going to copy one and paste it from this run window. Quite work. For some reason my copy and paste isn't working, so I'll just type it all over. There we go. Should Now, when I call getObject, I pass in the request I've just created, and I also pass in a lambda that specifies what to do with the response. Because the response is streaming, I'll only have access to it inside the body of this lambda. Once this lambda returns or is over, the response is cleaned up, the connection is closed, and there won't be any way to get access to this response again. So everything I need to do with this streaming response has to happen inside of this lambda. And what I want to do with this is I want to write it to a file. So I'm going to specify the path that I want to write it to, and we'll write it to some temp file on my file system. Uh, and we'll say response body write to file. Write it to this path. This write to file method returns a result. It returns the number of bytes that were actually written. So we can use that to print out an interesting debug message. Where we say we wrote number of bytes to this path. Run this and see what happens. All right, so in this case, it got into the Lambda body. It wrote the bytes that we expected to my disk, to my local disk, and it ended. The key thing to remember here is that this streaming response is only valid inside of this Lambda that's passed to this getObject operation. So once this Lambda is over, we won't be able to access the response anymore. Even if you saved the response to some variable outside of this closure, it wouldn't be valid once the Lambda was over. So you need to make sure that you handle all the streaming operations you need to inside of these Lambdas. That being said, there are a couple of different options for what we do with streaming responses. In this case, I wrote it directly to a file, but there may be cases where you want to process it directly in memory. So you could collect the response to a byte array. You should be careful with this because if the response is very large, then all of this will be put into memory on your machine at once. There could be you could run out of memory if the response is extremely large. But if it's not, if you know the size of it is small enough, then you can call to byte array and access the raw bytes yourself. Um, if you know the response is a string, maybe the file contains string content, then you can decode it to string, again, with the same caveat that if it's super large, you may run out of memory. But the, the takeaway is that there are a couple of different ways of handling these streaming responses from operations. All right. This is about all I wanted to cover for the basics of making calls. Let's hop a little bit into some more advanced topics. And the first one
Um,
that I
bef-
want,
Ian, before
yes,
we go further, I think it makes sense to address some of the questions that we have because they are kind of related to what you have shown right now. There was a
yeah,
very good question regarding the regions when you were specifying the region in the string.
yeah.
There was a good question if you have constants for that in the SDK.
Yeah. No, we don't have constants for that in the SDK right now. The list of regions that AWS supports are public and they're available with a simple Google search. But right now we don't have constants for them, like some of the other AWS SDKs do. Um,
Mhm.
so
All right.
if that's important, then I would encourage you to hop on our GitHub repository and leave us an issue, leave us a note that says that that's something you'd like to see.
I guess it's just the kind of intuitive thinking that something would help me to discover where is the list of available regions, and maybe with some tooling or documentation, it would be solved. There were quite a few questions already about the KMM support by this library. So, as far as I remember, you had some plans regarding that as well.
Yeah, that's a good point. I was going to hop into this a little bit later, but what I'll say briefly is that right now we're focused just on JVM support. And in the future, we definitely like to support native and JavaScript at a minimum. And we're trying to write our code in such a way that makes it easy to add that support later. Um, because that's on our roadmap, that's on our long-term vision. But we need to get off the ground with JVM first.
Right. There was also a good question by Andres. Is there a special reason why you opted to use lambdas instead of default parameters? That way you could have specified that the bucket is actually required for the list objects v2 call.
Yeah, so the answer there is tricky. We went back and forth on a couple of different ways of specifying these parameters using data classes, using default parameters, using lambdas. We settled on lambdas because we as the SDK don't control what parameters are required and are not required. And there have been instances in the past where some parameters that used to be required were no longer required or vice versa. Because that's outside of our control as SDK authors, we have to kind of leave it up to service teams to define those things, and therefore we can't know, unfortunately, which parameters are required and which ones aren't. We're looking at
Right.
ways to improve that before we go to full release, and so it's possible the syntax here may change, or there may be defaults that need to be specified. But for right now, um, we can't make any guarantees about which parameters are required or which ones aren't.
I see. There was also one question about the implementation details, but I think we can leave it for later because it's kind of, what we planned for the last part of the session. So I hope we will have time. So let's proceed now.
Okay, sounds good. Thank you. All right, let's talk a little bit about logging. The first thing that I meant to have here already was this link to our debugging guide on the uh, repo. If I open this up, uh, this is my little cheat sheet that I go to all the time for remembering what logging configuration can be set for the SDK. As it notes here in the documentation, we use the SLF for J logger for our JVM targets. And that means that any SLF for J backend can be used and configured to keep track of the logs that the SDK generates. In our case, I'm just going to demonstrate how the SLF for J simple logger works, but you could use log4j2, you could use logback, whatever SLF for J backend you want to use here to capture logs. So we'll hop back to our build configuration again. We'll add another line for SLF for J so that it's in scope. We'll refresh our Gradle configuration one more time. And then we'll actually write some code that should generate some logs. So by default, the SDK doesn't generate very many logs at the standard logging level. If I run just the list tables operation on DynamoDB without configuring any deeper logging support, I left the debug logging enabled from a previous session. Well, so what this is showing then is that at the debug level, the SDK does print out um, logs showing all kinds of things that are happening under the hood. It's showing it trying to resolve which region to connect to because I didn't specify one. It's trying to resolve which credentials to use. And at the very bottom of this list of logs, it's showing the actual call to list tables and the fact that we got a successful response. So at the debug level, this is what the SDK will print out. If I open up the run configuration in the IDE, I can show an example of how to configure at least the simple logger to use various levels of logging. So right now, it's a bit small, unfortunately. I can't zoom in much closer on it, but right now it's using the debug logging level for SLF for J. I can turn this up to trace logging to get even more logs. I can turn this down to info logging to get even less logs. But the debug level is what's going to show us some interesting stuff when I configure the SDK to show more logs than it's showing right now.
You could probably copy this parameter into the editor so it will be visible to everybody.
Yeah, or I can show this documentation page again because this is what we're setting in the IDE. This
Yeah.
simple logger default log level. This is the actual argument to pass to the JVM. In the IDE, that's simple to set in the run configuration. If you're running this outside of the IDE, there's other ways to pass arguments to the JVM. But whatever logging framework we're using should have options for configuring the log level.
Right.
So at a default, let's call up that screen again. At a default, it's showing us a lot of things about resolving regions, resolving credentials, a single line about making the request itself. But we can actually get the SDK to show us even more logging for a particular request. For instance, in our case, we could turn on an additional configuration parameter called SDK log mode. Here we can choose from a couple of constants that allow us to log the request itself or log the response itself. If we do these things, then what's going to happen is it will show us the request headers and the response headers that get sent back and forth to AWS. Let me expand this a little bit so that we can see it. But here's our request. So we can see which host it went to or which host name it went to. This is actually, a fleet of hosts behind this name, obviously. We can see the content length, the actual operation that was called, even the authorization header that shows us how the request was signed. Um, these these headers may be useful if you ever have to engage in a support case with AWS or get more information on what kind of calls the SDK is making. And because we enabled response logging, we also see the response headers. There's far less in the response headers, but there may still be something in here that's information. For instance, how big was the response that was sent back? If we want to see the actual contents of the request and the request body or the response body, then there's another set of configuration parameters for that. So log request with body, log response with body. These parameters will make it so that we see the actual body of the request and the response. If I run this now, the request body is pretty short because we didn't have any parameters that we passed to list tables. Then the request body is effectively empty. But the response body does contain something. It contains the full list of tables that was found as a result of this operation. Um, a word of warning about this is that when you're turning on this request and response logging, especially with the body printed out in the results, it may be possible that the requests and responses you're sending and receiving contain sensitive data. People use AWS accounts to store customer names and emails, to store credit cards, to store medical records, all kinds of things like that. Turning on logging for these things will put those data in your logs, and that may not be desirable all the time. So we recommend that you run with request and response logging turned off in production, and that you only turn this on if and when you need to debug something, or capture a specific case, and then turn it off when you're done.
Is it possible to switch the logging on without turning down the application?
Uh, uh, I'm sorry, you mean to switch it on without redeploying the application or without restarting it?
Yeah. Yeah.
Not currently, no. So right now it reads the configuration for logging at the time you create the client, and there's no way to change that after the client's created. Um,
I see.
that's interesting.
I,
Interesting
I, I
idea
I
though.
just I just thought about the use case when the application is running, and then I realize that something is wrong, and I want to enable this logging without
Mhm.
bringing down the application. Then probably through the JMX parameters, it would be, or a console, it would make sense to kind of provide this feature or possibility to change that.
Yeah. No, I think that's a great idea. Right now, like I said, you'd have to recreate a new client, which could be done at runtime, but you'd need some extra code to kind of handle that case where you're turning log levels up and down. Um,
I see.
being able to do it without restarting the application is an interesting idea.
Okay.
All right. So this was the basics that I wanted to show about logging. And again, like we showed the SLF for J simple logger here, but log for J2, log back, anything that works with SLF for J um, will be possible to use with the SDK. It'll just be up to you to configure it according to that backend's configuration parameters. So next I wanted to hop into a little bit about error handling. So all of the calls that we've been doing so far have been succeeding. They've been happy path cases. But let's set up a scenario where we want to make a call fail and see what happens. So I'm going to call S3's list objects to try to list objects for a bucket that doesn't exist. And what I expect to see here is some sort of error thrown that indicates what went wrong. Yeah, so bucket doesn't exist. What happens is I got a no such bucket exception, and this exception uh, occurred because I passed an invalid parameter to the call. Uh, there's all these exceptions that AWS can throw, that S3 can throw, that AWS can throw, are modeled in the SDK. So it's possible um, to write code that can handle them uh, by catching the specific exceptions that we're looking for. The exception objects will obviously contain a message and a type that indicates what problem occurred, but they'll also contain additional information called metadata. This metadata will indicate things like the request ID for the response, so that again, if you need to engage with AWS support, you can print out or you can hand them a request ID and say, this is the request that I tried that failed. Maybe you can find something more about it in your logs. There's information about whether the error is retriable or whether it indicates a throttling condition. These are also things that can be printed out or again captured to logs in some way about specific errors that occur. And if we do this, we'll see, here's my big long request ID. Here's whether the error is retriable. In this case, it's not. But there's extra error metadata that you can capture about exceptions that may help you understand a little bit better what's going on. One thing that I will say, though, is that retriable exceptions are generally things that you won't need to handle yourself. In this case, not finding a bucket is not retriable, but there are several conditions that are retriable, like transient network problems, calling APIs too fast, and invoking a throttling condition. And the SDK handles those by and large on its own. Every time you call an operation on an S3 or on an AWS client, it's automatically wrapping that call in retry logic internally, and it'll try up to 3 times to make that call, backing off each time if it detects a retriable error. Um, it's not easy to deterministically create one of these failure conditions. So what I've done is written a bit of code that I'm just going to copy and paste in here. And there's a lot of code here, but what's important is simply this. What we're doing is we're creating a new HTTP client to pass to S3, and we're basing it on the existing KTOR client that we already have in the SDK. But what we're doing with this client is every other request, every second request, we're allowing to succeed or fail. And well, the way we're causing this to fail is we're throwing one of these limit exceeded exceptions. There's a lot of code here, and you wouldn't ever want to do this in actual code. The only reason we're doing this is to create a faulty client that fails every other time to show how retries work. So I'm going to pass this faulty HTTP engine to the configuration for S3. I'm going to call the list objects operation. And what I expect to see is that it tries and fails, and then tries and succeeds. But I only see it trying and failing. Oh, right. It's still trying and failing because my bucket doesn't exist. I'll need to switch it to a bucket that actually does exist, since that is not a retriable failure. All right, let's try this again. All right, what I see is the debug message that I had in my faulty HTTP client, but I don't see an exception happening anymore. What I could actually do here is take the response and print out the keys that came back to show that it did wind up succeeding on a second try. There. So it printed out that my request failed, which I expected from my faulty client, and then it printed out the list of objects that it found, indicating that it did make a second attempt. We can see this even more clearly if we go back into the run configuration and turn on that debug logging that we had earlier. So if I copy my debug logging configuration, paste it into the run configuration, and then run this again, what I should see is an explicit log message saying this failed and I'm going to retry it. So this log message, if I scroll over to the right, because the font is big, says the list objects v2 operation failed. We're going to retry it. This is attempt number 2. If it failed again, it would make attempt number 3. If it failed a 4th time, it would give up and it would throw the exception that it found because it assumes that the the operation is not going to succeed after 3 tries. But in our case, we only failed once, and so after the end of all of that, we still printed out our objects.
There is a question in the chat, why is there no such bucket exception? But I guess it's the nature of this workflow that first you fail, but it's not an exception yet. We are going to retry, right? And then if like after multiple tries, if we don't succeed, then we throw the exception.
That's right. So the no such bucket exception itself indicates that you tried to ask S3 to list objects in a bucket that doesn't exist, a bucket that no one has created. And in that case, that's not a retriable failure. That's a thing that will fail every time until you actually create that bucket or fix the bucket name that you're trying to access. Um, so that's the first kind of error that we showed, and it's not retriable. The second kind of error that we showed was a fake error that we created that simulated a throttling condition, and that was retried, as we saw from the logs indicating the retry. Does that make
Right.
sense?
And is the number of retries configurable as well?
Currently, it's not configurable. It's set to 3. That is an item on our future roadmap, is to add easy configuration options for customizing the retry policy.
All right.
All right. If there's no more questions about error handling, then I'll move on to asynchronous calls.
Now, those were 2 questions that we had in the chat.
Okay, perfect. So let's start with asynchronous calls. And to do this, we're going to, again, alter our Gradle configuration. We're going to add support for coroutines in here. I'm going to paste in the Kotlin X coroutines library, and again, rebuild our Gradle configuration. Okay, now most of you will have noticed at this point that all of the main functions that we've been creating up to this point are suspend main functions. And that's because almost every call that we make to the SDK is a suspend call, and you can't make suspend calls from a non-suspend context. So we've been creating a lot of suspend main functions to enable those calls to our various operations. Here we're going to do something different. We're going to call run blocking instead. And that's going to be slightly different from a suspend call because it's going to create our coroutine context for us, which we'll need to do some of the fancy asynchronous operations that we want to do. Okay. So for this example, we're going to create another S3 client, create a DynamoDB client as well. And we're going to make a couple of calls to each of them. We're going to call list buckets for S3. We're going to call list tables for DynamoDB. And because we haven't added any special handling for either of these, then these are just synchronous calls. You can see that the IDE marks them as suspend calls, but we're not doing anything with the suspension point, and so they're just going to be executed one after the other. If we get the number of buckets from the result, say buckets length, and we get the number of tables from the result, and then print them both out, these will happen in serial. Sometimes, or much of the time, this is desirable. We want to make one call, we want to do something with the result, we want to make another call, do something with the result. But in a lot of cases, we can parallelize these calls such that they're both made in separate contexts and we can collect the results much faster than we could otherwise. To do that, I'm going to use the built-in async construct that's part of coroutines to turn this from an instant response or a blocking response to an asynchronous one. The same thing with the DynamoDB call. And now on these response objects, I'll have to call await to get the actual result. Now these calls to AWS are happening in parallel. They both should be pretty fast still, but now we can save the time of waiting for one to come back before making the other call. And ideally, we should see the exact same result printed out. What we can do, though, is we can turn on debug logging if we wanted to show that these calls are actually being made in parallel. Um, I'm not going to do that because with the window size we have here, there's quite a bit that would be shown on the screen. But um, turning on debug logging, if you wanted to do that, would show that these calls are being made back to back and that we're not waiting for the responses to come back before we collect the results. But this is a simple example of how to leverage the suspend calls that the SDK makes with Kotlin X coroutines to make asynchronous calls. Um, there's another example that I wanted to show of making a more dynamic set of asynchronous calls. So what I want to do here is upload a bunch of files from my computer to S3, but I don't want to upload them one after another. I want to upload them all at the same time. So I'm going to get a list of file names. Got a series of files I want to upload. There may be more. I'm probably getting this list of file names in real life from a list directory call, but for right now, I'm just going to hard code them here. Next, I can map each of these file names to one of these async calls. And inside this async operation, I'm going to print a debug message saying, I'm going to start uploading the file. I'm going to invoke S3 to actually put the object into S3. And I'll have to let it know which bucket that I want to use. And pass it the body of the file itself. In this case, we're going to load the byte stream from a file. Got a couple of imports here to make. But that should upload the file to S3. And then the last thing I'm going to do is print a message saying that I'm done uploading the file. Finally, this is going to return a map of asynchronous results. The way to get the program to kind of wait and make sure that they're all done is to call await all on the result. Again, this is something that's built into Kotlin X coroutines, so this would work with any asynchronous call. But we're going to make sure that the operation does succeed before we let the program end. All right, I'm going to comment out this code up here so that it doesn't muddy our results, and so that we're just seeing results from the file uploads. Now, when I run, what I should see is that all of the uploads began relatively at the same time, and all of the downloads finished, or all of the uploads finished, one at the relatively at the same time. What I didn't see was that it started uploading the bell and then finished uploading the bell. It started uploading the symbol and finished uploading the symbol. The uploads were interleaved, and that's because, again, these calls were made asynchronously. When you're dealing with large volumes of files, when you're dealing with lots of calls to various services, performing those operations asynchronously or in parallel may be advantageous to the code that you're running. All right, that was what I wanted to show with asynchronous calls. Any questions on the stream about that, Anton?
Not regarding this topic, no, but we have a follow-up question regarding the no such bucket exception from the
Yeah.
previous example. There was a question why this exception did not contain the detailed error message. For instance, the bucket name that we were looking for, and we got the exception.
That's a good question. So the exceptions themselves are left up to the individual service teams to kind of fill out. Like the service is what sends the response back, and all the SDK does is kind of interpret that response and turn it into an object. So in that case, S3 didn't return information about which bucket was requested. In our case, it was easy to look at the code and to see which bucket we were searching for. But in the case where that's not so straightforward, where we're not passing a hard-coded constant and we still want to know which bucket we tried to find and failed on, that would be a situation where some of that debug logging could help us out, because that would include the full request that was sent, and that should indicate pretty clearly which bucket we were searching for.
Right. And regarding this last example, there is a question in the chat as well. What if one of these async calls, async uploads fails? Will it be
Mm.
retried, or are there any retries? How does
Yeah,
it
so
work?
if the failure were a retriable failure, then yes, it would be automatically retried up to 3 times, like we showed in the previous example. So,
Hmm.
for instance, if we were trying to upload objects too fast to S3 and we hit a throttling condition, then the SDK would back off and retry a little bit later. If it's one of the non-retriable failures, then that upload would simply fail. And when we collect all these results with await all, then at that point, an exception would be thrown indicating which one didn't succeed, and we'd have to handle it using business logic in our program.
Hmm. I see. All right. And then no more questions so far.
Okay, perfect. Well, then the next topic I wanted to jump into was pagination. So all of the APIs that we've been calling so far have returned relatively simple, relatively small responses. What I want to do now is show an operation that returns a somewhat larger response, larger than the than can be contained in a single response. So I'm going to create my DynamoDB client, and I'm going to scan a table. In this case, the table that I want to scan is the world table that we saw earlier. What this world table contains is a list of geographical points, cities, countries, and what we're going to do is pull out cities from this list and display them. So our scan result has an items collection. We're going to print out a message saying we found X number of cities. And then we're going to print out the first and last city that we found as a result of this operation. All right, let's run this and see what happens. Now, the result that we got said that we found 6,000 some odd cities. The first one started with A, the last one started with C. And I know, because I populated this table earlier, that we have cities in this table from A to Z, and they're sorted alphabetically. So if everything came back in a single response, what I would expect to see is my first city started with A, my last city started with Z. I would expect to see a lot more cities here. So what's happening is that the response is too large to fit into a single response. There's too much data to fit into a single response. There's a further evidence that this is happening if I show the continuation token, or the last evaluated key. This last evaluated key is sometimes called continuation token, but it's a thing that's included on responses where pagination may be in effect. And so what I expect to see here is that there's a non-null last evaluated key. The way AWS services are built is that I can take this last evaluated key and pass it into a subsequent request to DynamoDB to get the next page of results, the next set of results in that list. And I can do that right now. I can say scan table is world, the The exclusive start key is the result that I got back from the last response. And this is essentially telling DynamoDB, continue with the results from this last evaluated key. Give me the next set of results based on that last page that you gave me. So I'm going to blank line, print these data again. I should see a new set of cities coming in from that second request. But I didn't. I saw the same cities. Not sure why that would be the case. This is one of those situations where, oh, I think it's because I didn't reset the cities variable. I'm still using the cities from the last response. So I missed copying and pasting that. Let's try that again. Okay, now I'm seeing a second list of cities come in. So my first request found cities going from A to C. My second request found a different number of cities going from C to G. And I could continue listing cities this way with more and more responses. But you can see that already we've got a fair amount of code in order to do this. Fortunately, the SDK has a built-in mechanism to automatically perform the pagination for you so that you don't have to write this code yourself. Instead of calling scan directly, what I'm going to call is a variant called scan paginated. I better just rewrite this code because I'm going to get it wrong if I just try to edit it in place. When you call a paginated operation, the result that's returned is now a flow. So flow is built into Kotlin X coroutines. It's not part of the SDK itself, but it's an asynchronous collection that's streaming. So we can collect just the items out of this response, collect them to some action that takes to some operation that takes an action on them. And in this case, we're going to print out each one of them. Name of each city. As we're calling the paginated version of this, I no longer expect to start at A and finish at some letter in the middle. I expect this to go through every city that we have in the database. But it didn't because I mistakenly put in cities for the table name instead of world. Okay, so what spilled out very rapidly in my console was a list of cities starting with A, ending with Z. And now I know, based on what I put into this table earlier, that we're seeing every result here because the SDK is paginating this call for us and making as many calls as it needs to get all of the results rather than just one page.
Mm-hmm.
All right, that's the basics of pagination. I see we're running low on time here. Anton, was there any questions about this or any other topic that we
Yeah,
wanted to hit?
it was kind of an expected question regarding the reactive nature of the APIs and if there is support for back pressure and so on.
Um, no, there's no explicit support for back pressure. The API the SDK will try to make the calls as quickly as possible, and it will back off in the cases of those throttling events. But there's no more pressure control mechanisms than that so far.
All right. And there was also a question regarding the previous example, I guess, about limiting the parallelism for the API calls. And I think what we have in Kotlin coroutines is the new addition of the dispatcher view APIs, where you can limit the IO pool, basically. but maybe something else as well. How would you do like limiting? Let's say I want to do not more than 5 concurrent uploads.
Yeah. So the SDK itself doesn't contain any mechanisms for limiting parallelism. That's controlled explicitly through Kotlin coroutines. So I believe the run blocking uh, operation or other coroutines operations take additional parameters indicating which kind of coroutine scope you want to use or what kind of parallelism parameters you want. That would be how you would set those. Additionally, what we did in this example was we took just a list of file names and we mapped every single one of them to an async request. But we could have taken this list of file names and chunked them into smaller pieces of work and only mapped those chunks instead of mapping each individual item. That would be another way of limiting this. But again, that's outside the SDK. That's the same method you would use for limiting parallelism for any Kotlin call.
Right. Then I think we can proceed. We are. I think it's fine that we run a bit over time. People are still watching us. It's an interesting topic, and I think we should proceed.
Okay, great. Well, yeah, there's just a couple more topics I wanted to get to. The next one that I wanted to get to was waiters. So let's again create a little main method here. Let's set up a trivial call that we want to make. Let's try creating a table in DynamoDB. Table is going to be called waiters demo. Now, the create table API for creating a table in Dynamo does take a lot of parameters. It takes the name of the table. You have to let DynamoDB know what attributes are going to be part of your table. So in our case, we're going to create an attribute called ID. And the type of this attribute is going to be a string. And then DynamoDB is going to need to know what the key schema is for the table, which attributes we want to use for keys. This helps us with sorting and with table organization. In our case, we only have a single attribute, so it should be easy to point DynamoDB to the ID attribute and say that we want to use the ID attribute for a hash key. Last thing to set here is the billing mode for the table, letting DynamoDB know how we want to pay for the table. We're going to tell it we want to pay per request, which is a way of reducing costs for tables that we don't use very often. Okay. After this API call returns, we're going to try immediately to put an item in the table. And the table name pass in is the table that we created earlier. And the item itself is just a map of attribute names, in our case ID, to attribute values. In our case, foo or something like that. We'll again print some debug messages here. All right, and if we try to run this, I believe it's going to fail. And it's going to fail for a particular reason. The reason is that creating a table is actually an asynchronous operation within Dynamo. So when we told it to create the table, we got a response back because we got to this point in our code where we printed our debug message. And then we immediately tried to put an item. But the exception that we get back from Dynamo says, I can't find this table. The requested resource wasn't found. And that's because table creation is asynchronous. It can take 1 to 5 to 10 seconds to create a table on the back end. So knowing this, or reading the documentation for DynamoDB, we could put a delay in our code. We could periodically retry this put item operation. But what we wind up doing is writing more code than we need to, because there's actually a mechanism built into the SDK to handle this waiting for us. So what I'll do here is I'll change this debug message to say create table API call is done. And then we'll call wait until table exists. Before I run this example again, I'm going to have to go back up here and change the table name that we're writing to, because even though my put item operation failed, my create table operation succeeded. And by now that table creation is probably done. So if I tried to create that table again, I would get another exception. So now we're going to create a new table. We're going to wait for it to actually be created before we try to write our first item to it. So on the screen, it's saying the API call is done, but it still hasn't come back and say the table is created. We're still waiting for that operation to occur. And in this case, it's taking a little bit longer.
It's polling for the service, right?
Exactly. Yeah. Behind the scenes, it's making regular polling calls to the service, and it's backing off a little bit each time to save you from hitting any throttling conditions. But now eventually it did succeed. It says it's actually created, and we were able to successfully put an item in the table because the table now fully exists. There are waiters for various conditions on various service clients. Not every operation or every resource type has a waiter, but you can discover them by using the autocomplete in the IDE to show you what kinds of waiters are available. In this case, we were waiting for a table to exist. For S3, you could wait for a bucket to exist or for an object to exist. Same thing with other kinds of service clients. All right, that was what I wanted to show about waiters. Any questions here before we move on?
No.
Okay. These last two sections here are not code sections per se. They're kind of items that I wanted to talk about to wrap up our discussion of the SDK. So behind the scenes, AWS it consists of a lot of different services. I took some numbers earlier this week and found that there are 297 services that AWS has. Across all those services, there's over 11,000 different operations you can call. We only saw a handful of them today, but there are literally tens of thousands of them. And for each of those operations, there's a graph of different kinds of objects, structures and enumerations and various parameters that account for what we call 73,000 different shapes in the SDK. What this means for you all is that as an SDK team, as a handful of engineers, there's way more operations and way more types of data than we can handle if we maintain it all ourselves. So what AWS has done, independent of our SDK, is create a tool called Smithy. Smithy is a public open source tool. You can go to GitHub and learn more about it. But what it does is it allows SDKs to abstract away the models for their services from the code that gets generated to support those services. We take the models that service teams provide to us, and we generate code based on those models to create the actual SDK that we're supporting. So we never wrote the list objects operation or the list tables operation by hand. We wrote a code generator that wrote those for us. In our SDK itself, we have roughly 57,000 lines of handwritten Kotlin code. But the models that get generated by the service teams lead to over 4 million lines of code that get generated and put into each of these service clients. This is the way we're able to scale as a relatively small team to be able to support hundreds of services and tens of thousands of operations. These service models change on a fairly regular basis. AWS service teams are launching new features all the time. They're adding new capabilities to their APIs. They're even launching new services on a fairly regular cadence. And so Right now, while the SDK is in developer preview, while we're less than version 1.0, we refresh these models about every week, and we release the SDK about every week. So you could go back to Maven every week and pull the latest version, and that would be how you would consume new AWS features. Once we go 1.0, once we're ready to be used in production, we'll be re-releasing the SDK daily, which will include every new feature and every new API that AWS supports. So in the future, it will be possible for AWS to announce some new service, some new feature, and in less than 24 hours, you'll be able to incorporate that into your code. But this is kind of a behind the scenes look at how the SDK is built and how we're able to cope with some of the size of it.
That's a great scale. So we have questions in the chat, but let's address two of those. I guess those cover all the variations that we had previously in the chat. So one of those is about the ETA. As usual, when you show something like a preview or alpha or beta,
Mm-hmm.
it's a natural that people would ask, when is it 1.0, when it's going to be stable.
Yeah, so I don't have a date, unfortunately, that I can give you. I can say that we went beta at the end of last year, and we're trying to make progress as hard as we can towards getting to production. But one of the things that we're still trying to decide internally that feeds into that is what's going to be in scope for our production launch. We're still trying to decide all of the things that are going to make it into our 1.0 release. And one of the ways that the community can help influence that is by coming to our GitHub repo, creating issues or upvoting issues that exist to let us know what's important to people, what they want to see in a release. The more things that are important to people, the more that may push out our release, but it's still going to help us get the best SDK we can so that when we tell people it's ready to rely on in production, we can actually stand behind that guarantee.
Right. And the other one was about the kind of coexistence of Java SDK and Kotlin SDK that you can use with Java. So there was like a question: is there like any value adds that Kotlin SDK brings compared to Java SDK?
Well,
Uh,
we certainly think so. Sorry, was there a second part to that question?
yeah, I tried combining two questions into one. There was like another part of this that I saw earlier. What was the reason for creating Kotlin SDK? I guess it goes into the same kind of bucket with the
Yeah.
question.
Yeah, no, and sorry for interrupting you. I was too eager to answer the question. So yeah, there is a separate Java SDK and a separate Kotlin SDK, and we didn't base the Kotlin SDK on the Java one. We wrote it from scratch to be 100% Kotlin, 100% idiomatic. And what we think that's going to mean for Kotlin developers is that they're dealing with constructs and dealing with library types that are more natural of a fit for Kotlin development. They're not dealing with a ton of JVM classes when there's better Kotlin equivalents that they can use. In addition to that, as I showed with some of the async operations, all of the parallelism that you can access is built off of Kotlin X coroutines instead of the older JVM like threading model. So again, I think it'll be a more natural fit for developers who are working in this ecosystem already. But one of the reasons that we did write it from scratch in Kotlin and we didn't just port the JVM SDK is to answer that second part of your question. What's the future for this hold? And that is, we want this to be an SDK that can be used in multi-platform projects. Kotlin multi-platform has this great premise of being able to write your business logic once and then run it on the JVM, run it in native compiled code, run it in JavaScript, other platforms in the future. And we want the SDK to fit into that as well. We want the SDK code that you write to be able to be written once and to work on all of these different platforms. So while we're only targeting JVM right now to get to our 1.0 release, shortly after we get to that 1.0 release, our top priority is going to be filling out support for those other platforms. And that's another reason why basing this off of the JVM version wouldn't help us get there.
Right. It's interesting. It covers all the four major, let's say, benefits of Kotlin that I have in my head, like the syntax that the library can provide to you, the idiomatic way of using those APIs, the types, especially null safety. So you could, when you call something, you can use this null safe operations and check for nulls also idiomatically, but I think of it as a separate value add of Kotlin. Multi-platform and coroutines, all four major values of Kotlin that like subjective tops from the list like are combined in this library. So that's very interesting to see.
Exactly. Yeah, as the developers who write the SDK, we've written a fair amount of Java ourselves. We've seen some of the pain points that come from using Java, and we're excited about the Kotlin language itself. And so it made sense when writing an SDK for Kotlin to try to use as many of those kind of Kotlin features as we could to make this the best SDK we could for this ecosystem.
Right. There was a question about testing, if there would be anything in the library to support testing. Because currently, when you use something for interacting with external services from your application, you are kind of writing the integration tests, right? You kind of fully test your application. And when we are talking about cloud services, it means that you probably will have to create some sort of a test account or kind of tests or mock those services in order to save money or anything like that. And one of those commonly accepted practices is to use now test containers with local stack, kind of
Mhm.
containerized. So the question is if there is anything in the SDK, in the new library, to support testing.
There are no explicit features in the SDK to support testing. All of the requests and responses that we pass back are regular objects that you could mock if you wanted to do unit style testing. But for integration style testing, we don't yet have any constructs in there to help that. But this isn't the first time the question's been asked. And so again, I would encourage people, if there is interest in this, to go to our repo, create or upload an issue about this so that we can make sure that it's prioritized in our roadmap.
All right, all right. We are severely over time, but it was
Okay.
very interesting session. Thank you, Ian, for coming and talking about this new library. I hope you will get new users to bring some more feedback to your team, and I strongly encourage people who are on the stream to try it out, and yeah, submit issues to utrack, and not utrack, GitHub actually.
GitHub,
Sorry
please.
for
Yeah.
that. Yeah, it's Kotlinish, right? We have
Yeah.
everything in utrack. All right then. Thank you for coming, and have a nice Kotlin, and have a nice day, Ian.
Thank you very much, Anton.